Good morning, sir.
Good morning.
process is working. Good morning, all of you. Good morning. We have started. We have started. Anyone who stops learning is old, whether at 20 or 50. Anyone who keeps learning is young. The best thing in life is to keep your mind young. With this quotation by Henry Ford, I, Anushri Roy, Assistant Professor in the Department of Electrical Engineering, wish you a warm good morning and welcome you all to 5-day International Faculty Development Program on Emerging Trends, Sensors, Security and Smart Automation Systems, organized by Department of Electrical Engineering, Mukhopadhyay Institute of Management and Technology, Kolkata. It's a great privilege and honor to have with us eminent personalities from academics and industry in this faculty development program. Hope this 5-day interactive program will enrich our knowledge in the field of sensors, security, and smart automation systems. Today, we have with us our principal, Professor Dr. Mukhopadhyay, and former Dean Academics, Emeritus Professor Dr. T.N. Chatterjee. Now, I would request our Principal Madam, Professor Dr. Mukhopadhyay, to inaugurate our Faculty Development Program. Ma'am. Ma'am, are you present, ma'am? Ma'am has joined us. We have with us our Principal Madam, Professor Dr. Mukhopadhyay. Ma'am, please inaugurate our session today. Am I audible? Yes, ma'am. Respected Professor D.N. Chatterjee, Professor T.K. Basu, all the esteemed speakers of the Faculty Development Program, head of the departments and other members of DPPINT family, and all the external participants. A warm good morning to all of you. At first, as principal of the institute, I welcome you all to this 5-day International Faculty Development Program on trends in sensors, security, and smart automation system, Electrical Engineering Department of Mukhopadhyay Institute of Management and Technology. This FDP will be held during 8 to 12 July 2020. During these 5 days, we will get the opportunity to hear from eminent academicians like Professor Subhas Mukhopadhyay of Macquarie University, Sydney, Professor Vishwanath Roy of Jadavpur University, Dr. Mukhopadhyay from IIST Shikpur, Dr. Anand Nag from King Abdullah University of Science and Technology, Saudi Arabia. Not only academia, also the flavor of industry will be provided by Mr. Devashish Gupta and Dr. Kalyan Modi, Private Limited. As head of the institute, I'm very happy that the departmental faculty members have planned to organize such a program during this pandemic situation to expand the knowledge boundary of the faculty members. I'm sure that that this FDP will be an enriching experience for all the participants. I truly appreciate this initiative of the department for encouraging the intellectual growth of faculty members. I'd like to extend my sincere thanks to all the speakers for accepting our invitation. Thanks to the coordinators for nice coordination, which I think is really difficult in this lockdown situation. Thanks to all the participants, and I wish the program a grand success. Thank you, ma'am. Now I'd like to request Professor Dr. B.N. Chatterjee sir to say a few words on this issue. Sir, please.
Good morning, everybody. Respected Professor Subhas, Professor Prof, Head of the Department, faculty members, the students, and the participants of the FDP. It is a great honor for me to say a few words. The FDP has been arranged on some topics which are of current interest. Although I personally feel that talking so much about some topics is really difficult. Let me cite two examples. The radar system. Radar system tries to find out the various things, particularly for enemy aircraft and others. But there are efforts to purge the radar system. That means with the help of something, and so we take care of it. We take care of the security of the system so that enemy cannot change it, cannot give us wrong information. Same is the case with our information system. Information system security is one of the very important things, and it has been taken care of. But even then, they try to break the security system, and we try to take care of it. And day by day, efforts are being made to this. And therefore, security is one of the very, very important things. And I am glad that in this FDP, participants are going to get a good idea, very good idea about these three aspects: security, information system, and sensors. I am sure all of you will be very, very much benefited with the deliberation by experts as well as faculty members and other staff of the Department of Electrical Engineering. And with these few words, I wish the faculty development program all success. Thank you.
Thank you, sir, for your encouraging words. Today, our honorable speaker is Professor Dr. Subhas Mukhopadhyay. I would request Dr. Nandita Sannal, Head of the Department of Electrical Engineering, to say a few words and introduce our honorable speaker. Ma'am, please.
Am I audible?
Yes, ma'am.
Yes, ma'am.
Warm good morning, Madam Chatterjee, participants from Kolkata and all over India, my colleagues. It is a to welcome you all to this 5-day international faculty program on emerging trends in sensors, security, and smart automation system. I welcome all recognized for part. I would especially like to welcome the speakers from abroad who have kindly consented to share their wisdom and insights. COVID-19 pandemic has significantly disrupted the higher education sector in our country. We, the faculty members, are totally confused about the future of conventional face-to-face education system. On the contrary, online faculty development programs, workshops are becoming popular as large number of audiences can have access to it. As the online system is much smart system, we must adapt it in higher learning also. During the faculty development program, you are going to watch 7 very effective presentations. There will be a YouTube streaming for the event. Every day, participants have to fill up the feedback form. So I am honored to have such a speaker who is having a prolonged biodata that I cannot finish. So welcome Dr. Subhas Mukhopadhyay. Sir, thank you very much for kindly consented to participate give lectures to our FDP, and welcome all the participants. Now please take over, sir.
Can you see my slides?
Not yet, sir.
So I don't know because I have not used this one. So how do I share my screen?
Presenting. You go to present now. At the right hand corner and bottom corner. Present now.
It can't share your screen, so it's not allowing me to share.
So coordinators, please allow Subhas Mukhopadhyay to share his screen.
For Friday one, I will organize my one here, okay? Because looks like it's not very friendly.
Allow everyone to share. Coordinator, allow everyone to share their screen. Have you seen present now, sir?
Yeah, I can see present now, but it's not allowing me to share my screen.
Now they will allow.
So it's telling you must grant permission in order to screen share.
Yes, coordinator, please allow.
Just a minute, I'm checking.
Please allow everyone. First you include son in the group. I think since he is not included in the group, that's why it is not allowing.
Before sir start, may I request all the participants to turn off their mic off in off condition.
Sir, you please press present now. Sir, you please press present now. কি হলো প্রেজেন্ট নাও করেছেন?
এখন অব্দি তো আসেনি।
Coordinators, please check.
Sujata ma'am, please turn off your mic.
Coordinators, please check.
প্রেজেন্ট নাওটাই তো টিপে যাচ্ছি, ওটা তো আমাকে পারমিশন দিচ্ছে না। এটা কি ফালতু একটা সিস্টেম, আমার বুঝতে পারছি না। এটা বলছে ইউ মাস্ট গ্র্যান্ট পারমিশন ইন অর্ডার টু স্ক্রিন শেয়ার। আমাদের জুম আউটে আমি জুম করতে পারতাম।
Only thing is that if it is unpinned, it is visible.
হ্যালো।
Sir, you have to enter through your Gmail account. Sir, you have to enter through your Gmail account.
দাঁড়াও।
Zoom में तो allow करते हैं. Sir, we are all allowed. So will you please log in through your Gmail account? Nandita, call him over the phone. I guess he's not connected over the internet. Oh, I'm calling him. Sir, आपके Gmail দিয়ে ঢুকতেছেন? নন্দিতা, স্যার মনে হয় হ্যাঁ নন্দিতা, হ্যালো নন্দিতা, শুনতে পাচ্ছ? হ্যাঁ হ্যাঁ শুনতে পাচ্ছি স্যার। বলছি কি, ওনাকে উনি বলো না ওনার স্ক্রিনটা যদি তোমাদেরকে কাউকে মেল করে দেন তাহলে তোমরা ওই স্ক্রিনটা দেখিয়ে দিতে পারো আর উনি প্রেজেন্টেশন দেবেন, সেরকম যদি হয়। হ্যাঁ হ্যাঁ ঠিক আছে, বলেছি মানে বলেছি। ওকে ওকে ঠিক আছে ঠিক আছে।
All of you, please bear with us. We are currently having some technical problems. Please taking some time. Please bear with us.
All of you are requested to please turn off your microphone. For better audio clarity, please turn off your microphone. It's working now. Yes, sir. Sir, it's working now.
Sir, it is working now. Dear participants, we are very sorry. We should have rehearsed it earlier.
So minimize the window and you can continue. We already see your representation.
Sir, you minimize your Chrome tab, please.
Sir, you minimize it. Sir, you minimize it.
Sir, we can see your window. You can minimize this tab and continue.
হ্যাঁ 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 এবারে এবারে আপনি ফুল স্ক্রিন করে দিন।
হ্যাঁ হয়ে গেছে।
এই তো। ঠিক আছে ঠিক আছে।
Sir, turn on your microphone. Okay. Can you hear me now?
Yes, sir. Sir, minimize the window, sir.
Okay. Yes.
Request all of you to turn off your mic.
Okay. So can I start?
Yes, sir.
Yes, sir.
Yes sir, you can start.
Okay. So actually we are engineers, so we now should make the. So today's topic is WSN, wireless sensor network, and IoT, Internet of Things, based health, home management, and smart city. So I am based in Sydney with the university name is Macquarie University. It's a government state funded university. We have around 40,000 students and over 2,000 postgraduate research students. Our university is quite famous because our earlier professor David Scalar and Professor Neil West, they actually developed the Wi-Fi, and everybody use Wi-Fi these days. So I'm actually delivering this talk as a part of IEEE Distinguished Lecturer Program, lecturer of IEEE Sensor Council, and Sensor Council is very active in the form of publications, which is IEEE Sensor Journals, IEEE Sensor Letters, Internet of Things Journal, and so on. Also, they organize international conference. One of these conference is the flagship conference, Sensor Conference. This year is happening in Amsterdam. It will be actually happening online. If everything goes well, after COVID-19, if we could lead a normal life, then we can have face-to-face conference in Sydney during October 31st to November 3. So I am organizing this conference in Sydney. So that's the call for papers to people after the conference this year, end of October. Okay, so today's topic is sensor, wireless sensor network. Different types of sensors for our day-to-day life, and very important because if we want to improve it, we have to is it to set the stimulus. Measured value is on. Huh? Nandita,
Sir?
you are also not able to listen
Yes, we can listen.
because some people call me that they are not able to listen.
From which country? This country?
Yeah, from India only, but some other part like Delhi.
Maybe they are having some network problem because we can listen very well.
Okay, so I think I'll go ahead.
Yes.
Okay, so the sensor is a device which actually measures some physical stimulus. Anything physical means it can be heat, light, sound, pressure, any other parameters. and it gives us some measured signal which we can use it for some purpose, or we can transmit it, we can process it, or we can do whatever we like. There are different things like sensors, pros is transducers. Also we know something called actuators which actually does some actions, transmitter which transmits signals mainly wirelessly, and the stimulus is something which we measure. Those who are involved with the research in sensor area, either they could actually use sensors which are readily available in the market and make sensing systems. I'm showing in the left hand side those who are involved research on developing new sensors for some exciting applications. As I have shown in the right hand side, they could actually fabricate sensors for different applications. So today's topic is for health and home management. The big picture is called smart home. So smart home is a place where we can think of some environment where people live safe, sound and secure way. And on top of that, it provides a place where you can live independent lifestyle. So the question is, why smart home? The smart home is very important because we now live much more longer than earlier generations. Very surprising to see someone live more than 100 years. But our physical structure, our DNA still did not change much. So usually people retire at the age of 65 or 70, and after that the lifestyle makes them too old too quickly. So we need some help for our day-to-day life. But not only that, sometimes, as you can see here, the person showing in the right hand side, and due to something he actually died, but his death was not known to others for quite some time. This particular person's death was known after 21 days. Happening because if you see here statistically, almost like 35% people live alone, independent lifestyle. When somebody is living alone, there is always a risk. So what we are proposing here is technology, combination of sensors, smart processor and smart communication device, wireless sensor network, or even Internet of Things, because the data can be available in the cloud. Combination of all these can provide an environment where the old home can be transformed to a smart home. So here where we are showing is that some sensors which actually measure the day-to-day lifestyle, different activities of the persons, and the data is measured on real time, converted to the processor, where the processor processes the raw data and find out whether everything is normal. So we are working in this area for quite some time. We have developed different sensors. Also we have developed sensing systems, and those sensor sensing systems are used to monitor different activities. So this is a house where it's a very old house built in 1939. Many sensors are installed and the house converted to a smart house, smart home. How many sensors we need depends on the size of the house. It also depends on the lifestyle of the person. So a old person is living in that house and different activities are monitored. But the difference of this research with respect to the research carried out in the university is that here the sensor has been installed in the old home. So it becomes a living lab where different activities are monitored, and it's continuously monitor different activities. The sensor provides the raw data. Sometimes the raw data is not good enough. You need to have some processing. So raw data with time stamp are all collected in the data acquisition systems, which is basically the receiver of the wireless sensor network. These sensors are all Zigbee based. So during that time, last 4-5 years back, all sensors were developed based on Zigbee. Whether you use Zigbee or use Wi-Fi, that depends on many factors. Wi-Fi consumes a lot of power, so effectively Zigbee is a good option. These days, there is another transceiver coming out. It's called LoRa, Long Range Wide Area Network, and people have started using that for smartphone too. All the data are stored and collected, and then the stored data are processed to determine or to recognize different activities of the person. And from the activity, the wellness, that means how well the person living, they are determined. So we quantitatively determine the wellness of the person. We are showing all the software related activities what we do. Of course, most important thing, we collect the raw data, and then from there we determine what activity, what event. And after we do all these things, we have some machine learning software where we determine what is the behavior of the person. And the behavior means what type of activity the person does every day. And as we know, with time, person's habit changes, person's lifestyle changing. So we need to have the software which will be able to change itself, adapt itself with time. So we use different types of machine learning algorithms for data analysis. And how do you determine what type of sensors you need, and how do you determine for a particular person those sensors are the best? So at the early stage, we determine, depending on the person's daily life, we determine the initial sensors, and those sensors are installed. And then if you see the frequency of usage is not significant, then you can ignore that sensor, and other sensors you can continue for 24/7 usage. So here we are showing some of the data and what we did from there, how do we annotate the activity, and from there how do you determine the lifestyle. In terms of the people wellness, we have defined some quantitative value or quantitative measure called wellness function. So one wellness function is based on inactive usage of appliances. What does it mean? That sometimes we do not actually use any sensor. So that means whether person is actually monitored during that time. If you do not use any sensor, that means the person is not using any sensor, so you cannot tell about the person's activity and how long you can afford without any sensor data. So that is the one wellness function we define, and it is based on, if you see that person is not using any sensor, that means person's activity are not monitored for a long time, anything about the person's wellness. So that's one of the risks. So you need to get the information. Another important wellness function we define is called excess usage. Excess usage means some of the sensors are used too much. So for example, on average, persons may sleep 10 hours. So nights 9 o'clock, person might go to bed, and morning 7 o'clock, person get up, on average 10 hours. And then I'm talking to old people. Of course, young people, they may sleep 7 hours, 8 hours. But if the person sleep more than that, then you may actually consider something irregular. So that is defined another wellness function. And many actually incidents are reported that persons actually are on bed, but so that's what we have defined another wellness function, which is based on excess usage. From the data what we collect, it's also possible that we can predict the trend or the change of behavior of the persons. So based on the last few weeks of data, we can actually predict what is going to happen next week. And this is also important because when you think of that you are comparing something which you consider as a regular life, actual measured data, how do you ensure that your regular life is based on current data? So that's why this prediction is important, and this predicted value is considered as the regular value. So we can predict, and this is very similar the way we forecast the share market. So it's time series analysis. So forecasting is basically based on the earlier data. You predict some kind of machine learning algorithm. So here we show different types of trend depending on the some activity, and we can actually predict that activity is used, the prediction is used as the regular data for comparison. Also, we have the sensor in the house where we could actually track the person. So the tracking means you know the location of the person. And this is very important. Sometimes the old people, they fall down. It didn't happen. So if you know the location of the person, you can actually interpret whether you have some issue with that, with the movement. The person is fallen down or so. So this is also important for the smart home monitoring the people. I'll talk about a little bit about our current activities. Our current activities, what we do here, we develop different types of sensors for different applications. So our sensors are basically, we call capacitive sensors, planar interdigital sensors. This is a very important sensor for characterizing different types of dielectric material, and very important for different parameters related to blood, water, and so on. So can be used for health monitoring, can be used for environmental monitoring, and so on. Earlier days, we used to develop sensor based on namespace technology, microelectromechanical systems. As you can see here, the picture, which is silicon wafer. On top of that, sensor has been fabricated. And you can use that sensors for measuring different parameters. This is high sensitivity, but when you measure, sensitivity alone is not the most important thing. It's one of the important parameters, but it's not the only one. What we want is also to determine selective parameters. So selectively you determine some kind of chemicals, some kind of biological elements, so on. So we developed something called molecular imprinted polymer based technology for the selectivity. And this is important that you could easily prepare something at low cost. You could also store it for a long time. It provides high mechanical strength and so on. And also it will be able to operate in the hot and harsh environment. So that's what my lab, my students, they developed. One of the applications we had earlier days was called osteoporosis. So early stage of osteoporosis. Osteoporosis is related to the bone loss. So people at the age of 45 to 50 plus, it's more common in women than men. They actually fall down and break some part of their body, and this, when it happens, doctor after many tests, they actually can determine that okay, the person is suffering from osteoporosis. So here, in order to develop a sensitive selective coating, what we have done is to develop the selective coating material. It's based on polymer. So the polymer process takes 24 to 48 hours, and it follows some procedure. You need some functional monomer, some kind of template, some kind of cross-linker and solvent, and so on. Once you make this, then you can actually extract that information, extract the molecule, your target molecule, and then you functionalize it on top of the sensor surface. So surface, you have the sensor with code, and you can apply your target molecule and you measure the data. So earlier days we use antigen antibody method for detection of the pathogen in meat and in some other food related items. So that's a different way of measurement. That's antigen antibody method. And later on we also developed protein application. So E. coli bacteria can be detected. Later on we developed some systems where we could monitor or we can detect the contamination of plastics in water which come from the plastic bottle, and that is called DEHP, diethyl hexyl phthalate. So the phthalate is contaminated in water coming from plastic bottle. For the osteoporosis, the current technique is basically based on X-ray. So as you can see here, the picture, the X-ray is taken, and from there you can actually calculate what is the mass of the bone, and after 6 months or 1 year you can have another X-ray, you can calculate the again mass of the bone, and from that you can determine what is the rate. If the rate is too high, then you can say, okay, person is suffering from osteoporosis. And that process takes quite long time, up to a year or more than that. So our process is not based on bone X-ray, but is based on blood. When the bone lose mass, bone actually produces a lot of protein, and that protein is mixed in the blood, and that protein called C-terminal philopeptide, type 1 collagen, and we can determine that, and we know if we measure every week or every 2 weeks, and we can see how much is the change. From the change you can tell what is the trend, whether the person's actually bone is losing the mass, and that's very useful. And the data can be uploaded into the cloud where a doctor or general practitioner can tell you that you are suffering the problem, and then the treatment can start at early stage. So my student developed the sensor, and actually now we are extending it instead of blood, we are extending it for urine. And also another parameters is useful is called creatinine. So one of my students working on the development of sensor for creatinine detection. So when we have that, we'll have an array where the array can determine creatinine, C-terminal philopeptide along with calcium. And if we could think of in future, all these three sensors in the form of array can be installed in the toilet, and persons don't need to actually collect the sample. So urine will be automatically detected there, and all the parameter will be measured, and then parameter will be uploaded into the cloud, and where the doctor can measure the data, can see the data, and then the more tests will be done, and then treatment will start. So right now, last few years we are working on, my groups are working on different types of flexible sensors. A flexible sensor is very useful for wearable applications. MEMS-based sensor has some issues, so that's what we are now moving into the flexible sensors. So the flexible sensors, another important advantage is flexible sensor also can be sensitive to strain and stress, because the dimensional property also can give us information. So that's very important. It will give you the change of resistance as well as change of capacitance, because the dimension changes. We use different types of material, whether you use PDMS or PET or polyimide film or carbon nanotube or graphene. Each one has got its own advantage or disadvantage. So that is very important for the selection of the material, and depends on what type of applications you have in your mind. So different types of sensors over the last 3-4 years here at Macquarie University for different applications. It can be some healthcare application, it can be environmental applications, or it can be industrial applications. So last part of the talk, I will talk about the recent project what we are currently doing. It's called Smart City. Here the major data we are putting into the cloud through Internet of Things, and this is mainly for the counting the pedestrian as well as the ambient monitoring. So here for the pedestrian counting we use pyroelectric sensor, PIR sensor. So the PIR sensor has got different advantage compared to other techniques. Whether you use camera or you use RFID tag or you use Wi-Fi reader. So in terms of the cost, in terms of the power consumption and detection ability, each one has got its own advantage. But one of the most important requirements sometimes is the security aspect. So you do not want to divulge the identity of the person. So camera or Wi-Fi reader may not be applicable. So there PIR sensor is the best candidate sensor for this type of applications. This type of research is going on in many parts of the world at this stage. So whether it's in Australia, Sydney, Melbourne, or even New Zealand, or America, or Ireland, Spain, they have got different types of sensors, different types of features they try to extract, different way of installing the sensors, but most of them use electric pole. We also use electric pole. The communication technology, you can see either they use 3G or 4G. Here you are using LoRa, long range wide area network. Second thing is the power consumption. Our system is the solar power based, so the power consumption is not a big issue. And of course, the cost is important for any engineering system. So we are actually going for a low cost system. So our sensors are installed on electric pole, and it's actually installed at a height of around 3.5 meter, and we can monitor a footpath of 3 meter to 3.5 meter wide. And we have changed the focus in such a way of the PIR sensor that we can actually avoid any fade up to 1 meter height. So that's the interesting thing here. What we have changed is the field of view of the PIR sensor. Along with the PIR sensor for pedestrian counting, we have an environmental combo. So just continue the PIR sensor. So we have PIR sensor we use for the reason that it's a low cost, its power consumption is very low, and it does not intrude the privacy, and it is based on the movement as well as the body heat. So we have used some technique to change the focus of the PIR sensor. So along with that, we use environmental combo where we can get quite a few parameters: temperature, humidity, air pressure, carbon dioxide, as well as the total volatile organic compound. All these things comes in as environmental combo, and which has been interfaced with the microcontroller based on I2C protocol, and we collect all the data. So this is the electronics we use here, and most of them are coming into the microcontroller, which is Arduino based, and we collect the data, and then we connect it to LoRa and put it into the cloud. We use the battery, which is 6,000 milliampere of battery, and we use solar panel for charging the battery. This battery 6,000 milliampere hour has been chosen for some backup if we do not have amount of sunlight for a few days. So that's the electrical connections. Now in this case, we use PIR sensor which has 6. The reason is we also can tell about the direction of the pedestrian movement, whether going from left to right or right to left. And three sets are used because we can actually tell different people, and sometimes it happens people actually working together, so we could determine them without much error. So we have developed some kind of algorithm for making the accuracy of the counting very high. So if we have more without much gap, then what happens? The PIR sensor give you the high signal, which is not for one person, for multiple persons. So we have developed an algorithm which actually tell you how many persons are actually going. So that's really very good. And also we developed a machine learning algorithm to get higher accuracy. We are showing the battery life calculations. So how much power is consumed for each sensor as well as the LoRa transceiver, and based on that we have got the average power consumption and how much that average power lead us to the battery. Assuming the battery efficiency is 65%, so we can get around 4 days of power backup. So that means if you do not have sunlight for consecutive 4 days, the system will still operate. Now in Sydney, it sometimes happens that we may not have sun for many days, up to a week or so. So that type of situation, the system may not work at all. So that's the design of the systems, and we have many sensor nodes actually installed near our university area, all total 74. Not exactly this one, but it's a different type we have installed for monitoring. Most of them are working, few of them are having some issue, but most of them are working well. So that's the architecture of the complete monitoring system. The sensor node, after measuring the data every 10 minutes, the data goes to the gateway, which is LoRa based, and then it goes to the cloud. And in the cloud, data is saved, and also then we have another server where the data is stored. And after that, we develop different types of apps where you could use the data for visualization. So that's the picture of the different sensor and installation. So the current sensor what we have is like based on this is JK box, normal box available in the shop, and we have used that to make it cheap. And we have developed a algorithm to make the accuracy very high. So that is based on the relationship between actual count and the count by the system. And there we have developed something which actually gives us very good accuracy. So this is the data for throughout the day for different times, and we can see the error rate. So the error rate goes maximum like 9%, but after we develop the algorithm, we can make the error under 3%. So that's the different result which actually you can see in the IoT server. So here, people coming from one side, directions, and number of people, and then this one we are showing temperature, humidity, carbon dioxide, pressure, and total volatile organic compound. So for some time of the day, and now we are trying to correlate that whether people movement has any relationship with the environmental parameters. Of course, we know that it's very difficult to correlate, but we are trying to see any kind of relationship between the pedestrian and other environmental parameters. And then once we have all the data, it is possible to use the data in different ways. So one of the things which you can see is to develop different types of apps. That apps actually can take also the location. So one of the important things is that sometimes you may think that, okay, I've got how many people are actually in this area, and whether I could go to a bus stop where I can get a seat in the bus, this type of things. So you can see number of people, and that actually tells you whether you could walk a little bit more to go to the next bus stop and so on. So that type of interesting things available in different ways, but those are taking the data from the Google Earth, but this one is actual measured data which you have in the system installed locally. Okay, so I will stop here. So basically our work, we develop different types of sensors, and we call the sensors are IoT enabled sensors, Internet of Things enabled sensors, and those sensors are very useful monitoring different health parameters or monitoring different environmental parameters. Develop is very easy to use, and also it can take the new sensors without much problem. And these days, Internet of Things enabled sensors has a huge potential because Internet of Things is expanding and getting a lot of new applications. So if you have sensors which is IoT enabled, it can be.
Sir, one more question is there. Ranjana Goswami ma'am, she is asking what kind of sensor can be used for swab test.
You see, the problem is that it is possible, but we don't do any work because it's an infectious disease and highly contagious. So it's actually very difficult for. So that's why it is not done by any sensor. It's always done by PCR technique.
So actually, notice that.
Ma'am, please unmute yourself. Ma'am, please unmute yourself. Ranjana ma'am, please unmute yourself. Yes.
What I'm trying to say, sir, is that it might not be for COVID-19, but even for simple tests, to start with, to check the simple things, to start with, can we do some, it might not be prodigious to that extent. Can we do some sensors there? I need to know that what should be the best one.
Actually, if you think of some wearable sensor, then it depends on whether you are looking for the early stage or you are looking for, whether somebody already has. If have, then of course the situation is different. If somebody you want early stage, then there can be some parameters which will to determine. So So can you see the slide?
Yes, sir.
So that was my different talk I gave last week. Actually beginning of this week. So if you want to think of something you want early stage detection. People have got fever, people have dry cough, people have tiredness. So you need to measure the temperature and you need to also measure the tiredness and then the breathing rate. That along with the and some kind of speech, whether the speech is getting lost, is develop wearable sensor. Now, when you think of swab, is actually it's very difficult for somebody doing at home. It's a laboratory-based system because chemical sensor or biological sensor, they are not very good for home applications. Good for the laboratory, but you can get early indications if you have those sensors what I have listed here in the left hand side. If somebody thinks that he has some kind of problem which may looks like COVID-19, then of course he needs to consult the doctor.
Thank you, sir. Sir, one more question is there. Can you, sir, Dr. Shonali Vishwas is asking about the MEMS sensor that you have developed. And is based on which type? She is asking that MEMS sensor that you have developed is based on which type?
Which type means is it material or is it the sensor is silicon based, silicon technology, but it is developed called capacitive sensor.
Okay. Dr. Shonali Vishwas, are you there? If you have any question, Dr. Shonali Vishwas, if you have, you can directly ask, sir.
If I am there.
Yeah.
Yes.
So just let me know what is.
Yes, you have asked.
The MEMS sensor which is in laboratory, what type of that MEMS sensor which you have developed?
So time is basically we want to have capacitive time. So it's a planar capacitor. So we operate at very low frequency. We operate very low frequency. So you want to know the fabrication process or what?
No, I want to know like what is the time? Like it is based on capacitive time. Whatever you have developed, like.
Yeah. So interesting thing is that this sensor actually give you two parameters. One is the capacitance, another is the resistance. Because this is not ideal capacitor. So you will have some kind of conducting material. So the resistance also play important role. So we can measure both capacitance and resistance, and from there you can determine the properties of the material you want to test. So interesting thing is that this is the same what developed part. Depends on what material. So we have used earlier we have used antigen antibody for E. coli bacteria, and then we are working on the molecular integrated polymer technology for selective coating.
Okay. So what is that? You're taking in terms of certain fluid, or it is just that air gap you've taken?
So it depends on whether you want to pipetting the target molecule on your sensor. That's one way, which is very popular in the laboratory. Or also you can dip the sensor into the sample. So, so for example, if you think of measurement of something from the rainwater, then you can allow the rainwater to come onto the sensor. Or you can, so for our nitrate measurement, what we did, we actually pump water into the sensor container, and then the sensor measure, and then we pump out water. So it depends on the applications. You have to make the system to operate.
Okay. Thank you, sir.
Yeah,
Thank you so much.
Thank you. Sir, one more question is one more question is there from Mohit Angurwala. Understand?
Yeah.
Yes. Before that, Dr. Joydeep Nath is asking. In WSN.
So moving sensor means basically to serve has been designed and somewhat.
বলো হ্যাঁ দাও দাও দাও
Now the solar panel will be depending on the maximum sunlight. So you know the focus angle of the panel with respect to the location of the earth and sun. So you have to have, so in Sydney we have around 17 degrees. So solar panel is directly connected to the battery. So the battery will give you the power when the solar panel is not giving you power. So during the night time and early morning and late afternoon is there, then you get the power directly from the solar panel. Otherwise, solar panel will charge the battery during that time.
Another question is from Shobha Gupta. What are the best softwares for simulation of MEMS?
It depends on what type of simulation you want. So we use in my lab we use finite. So it basically, if you think of effect of some dielectric material, some conducting measurements of the sensor, then finite element analysis we use software called console multiphysics. But also it depends on if something like a lump parameter based, okay, then you can use some other types. If you think of the software is like antenna, then you can use something called CNT software. So there are different types of software, depends on what exactly you want to obtain, depending. If you think of that power is obtained from wireless field, unfortunately there are not much power you have for charging the battery. So there are many papers reported and they are under very controlled environment where the power obtained is good enough for the sensor operation. But if you have wireless transmitter, the amount of power may not be good enough. So wireless charging is not very popular if you have some sensor which are used for regular monitoring or some kind of critical applications. You cannot rely. So energy harvesting is a topic where they look into different ways of generating power. Wireless charging is one of them. They don't say wireless charging, they say RF energy harvester. So it's not very popular in the sense of getting right amount of power.
Thank you, sir. Sir, one more question is there. Is solar charging the latest method to recharge sensor?
It's not latest, it's the oldest maybe, but still very popular.
Okay, thank you, sir. No more questions are there. So now I would request our coordinator, Dr. Shubhas. Yes, ma'am. Yes, ma'am. Sir, people are asking for your PowerPoint presentation. Sir, participants are asking for PowerPoint.
I will see whether I could reduce it because it's more than 20 meg, which I'll try to send it to Nandita and I'll see if it goes. Otherwise, I will reduce it to little bit lower size and then send it.
Okay, thank you, sir. Sir, now
okay. By the way, Nandita, do you think that because this system allow you only 100 people, so on Friday, do you think I will make a Zoom from here? Okay, then I will send you the link.
Actually, sir, we are having YouTube streaming as well. So there are also answers there in YouTube.
Oh, okay.
So if you want to have Zoom as a platform, you can send us the mail. We will mail it to the participants.
No, I think let us then go for that because many participants have got the link which you have made. But I hope that it will not have problem on Friday.
Okay. Thank you, sir. Thank you, sir. Now,
any more questions?
No, sir. We don't have question. Now we are having a short appreciation session, sir. I would request our coordinator, Dr. Sudipta Chakraborty, Associate Professor of Electrical Engineering, to speak a few words and felicitate our speaker. Sudipta ma'am, are you there?
Krishnamurthy ma'am, are you there? Nandita ma'am, I think Shudipta ma'am is not there. So could you?
Yes, Shushmita. Shushmita, you shared the certificate.
Yes.
Yes, yes. Sudipta is there.
Shudipta ma'am, please.
Sorry for the technical glitch.
Speak up. Okay, thank you.
Am I
Please
audible?
speak up. Yes, you are audible, ma'am.
Very good afternoon to our esteemed speaker, our dignitaries, participants, my beloved colleagues. This has really been a very, very enriching experience. We were really enlightened by Sir's talk. It was very much valuable, and the way you have delivered in lucid manner, I guess all the participants should be really appreciated. And we got to know about the applications, the uses of sensor in human anatomy, in different environmental situations, and the question answer sessions of lecture. And now I would request, I would thank Sir wholeheartedly on behalf of our department, on behalf of the organizing committee, and on behalf of the college. And I would request now Shikshika to share the certificate. So this is a very small, small solicitation ceremony. So this is all online, and we must thank him as our Suri ma'am has usually thank him for giving his time and spent. And I believe the class enjoyed a lot. And I also would like to thank all the members of the organizing committee for giving such audience favor to make this program a success. Can you give your clap for Mr. Nandita from the department? All of you, all the participants, unmute your microphone, give a clap for Sir. Very good lecture.
Thank you very much.
And all of you are not see your video. We just have a short photo session. All of you please turn on your video. We will have a short photograph session. Sujata ma'am, please take a photograph.
Shushmita, pause your screen. Shushmita. Oh my God. করেছি অফ করেছি Hey, I am visible. Yes, am I visible?
Yes.
You have taken a photograph?
Yes, I have.
Yes. Then all of you, those who are having photography, your video off and let others come.
Thank you all of you. Tomorrow we will be having our session with Mr. Devashish Gupta. From 4 o'clock the session starts. All of you will join. Sharp at 4 o'clock our session will start. Thank you all of for today.
Now take a photograph. Sir is there.
Yes, I have taken. Thank you. I'll take it.
Then.
Thank you, sir.
Now I will request everyone to please join 20 minutes before the program to avoid the bottleneck problem. Because participants are there, lots of participants are there, so you please join before 20 minutes of the program. Yeah, I think I will do that on Friday, half an hour before, so we can take any problem.
Okay, sir.
Okay, thank you. I'll then leave now.
Yes,
Okay, sir.
sir.
Thank
Thank
you.
you.